Okay, we see another problem in square prism. So you can see in this problem, we have to construct a square prism of dimension 35 and 60 axis length. So rest on HP on one of its corners of the base. So the first position starts from the corner here. Okay, then after that you can see that draw the projections of the prism when the axis, you can see that. So when the axis of the prism is inclined to HP at 40 degree and to VP at 30 degree. So they have mentioned here axis. Okay, so both the angle of inclination, you can see that it is there with the axis for HP 40 degree, VP 30 degree. So it is an beta angle problem. Okay, first initially we are going to construct here. First, we'll take a reference point here. So by taking the reference point, we have to mark at 45 degree because so marking at 45 degree. So we have to draw an angle line here. Okay. So dimension it is 35. Okay. Dimension 35. So I have to cut. Okay. So we have to take it a little over here. So first we know that we have to draw an XY line, right? So first we are going to draw that. So VP, HP, Y. So now we can mark a reference point here. So marking at 45 degree. Okay. So we have to measure 35 because square of dimension 35 here. So 35 you measure it and cut the arc. So you can show the dimensions on one side here. So you can write the notations here. So top view notations are A, B, C, D. Bottom pair notations are A1, B1, C1 and D1. So to find out the center, we'll be drawing a thin line here. Drawing a thin line. So we're getting O and O1. So now we'll draw the front view. So you know that the front view of a square prism, it is a rectangle. So we'll use the axis length 60 mm. So 60 means 6 boxes. 1, 2, 3, 4, 5, 6. Mark here. So here your axis is not visible because BB1 end it is covering the axis. So that's why it is a continuous line. So now we have done with the front view. So now we write the front view notation. First we finish with the top view, top face. So A dash visible, B dash also visible, and C dash visible, but D dash not visible. Similarly for the bottom face we have A1 dash visible, B1 dash visible, C1 dash visible, but D1 dash not visible, and O1 dash and O dash are also not visible. Now we see that inclination to HP they have mentioned 40 degree. Okay, first I will take a reference point here. Reference point I have taken, that is C1 dash. Okay, C1 dash. Taking the compass here, so I will be marking at 40 degree. Okay, marking. So here in what you have to do is, so before so here in we are doing the base edge inclinations, right? So here the concept here, base edge inclination. Base edge inclinations is equal to 90 minus 40 degree, that is 50. So we have to incline it, we have to mark at 50 degree here, okay, not 40 degree. So that's what the base edge inclination here. So we have to mark at 50 degree. Okay, so 40 degree given, we have to mark at 50 degree. Okay, 50 degree. To drawing the arc, we have to transfer these things here. First arc, second arc. Okay, this is A1 dash, so 1 dash, B1 dash and D1 dash. So now to these points we can mark at 90 degree. Because you can see this with respect to this base, these lines are exactly perpendicular. So after drawing 90 degree points, putting a 90 degree point, so just draw a straight line here. So the straight line of length it is 60. We will draw for 60 exactly. So because it is 60. Okay, so here we will name it A dash, B dash, D dash, C dash and O dash. Now you extend this. Okay, this is our axis line, right? You just extend it. Now you find out the angle. You will get exactly 40 degree. Okay, so exactly here, getting 40 degree. So remember it, base edge inclination, that is 90 minus angle of inclination to HP 40. So it is 50. So inclining this one to 50 degree in order to get 40. Now the second position, top view. So now we can write the notations. First we'll write for the top face. Okay, the top face notations here: E, B, C, and this is D. Similarly, we have this one: A1, B1, C1. This is D1, and we have this is O. This is O1. Okay. So now we know that we have three concepts in writing second position top view. First is the outer boundary line. You can say that I'm starting from A1 here, drawing the continuous outer boundary line, D to D1, D to C, D here, then to here. This is what the outer boundary. Now visible faces. As you're looking these things from the top view, so this top face it is visible. Triangle, it is a square, right? So we will join that. This is top face which is visible, ABCD. Okay, and this side A dash, A1 dash, it is also, this edge is also visible from the top view. A1, that is also visible. Okay, now we can see that this bottom square, it is not visible from the this face not visible from the top view. So a part of it already we have written, part of it will be written with the dashed line. Okay, so now the see that C1 and C, this is also dashed line, so it is already a continuous line. So part of it we can show it here with the dashed line here. So there is a concept here: if there is a merging of continuous line with the dashed line, we have to show only the continuous line. Okay, so remember it. So now we have almost done with the so here part of the axis also we can show here. Okay, now you can see that this is a beta angle problem. So first initially we are going to consider, we'll be drawing a parallel line here. Straight parallel line. I will take a reference to this. So I'll be drawing an angle line 30 degree. Okay, so 30 degree angle line. So after taking a reference point and drawing an angle line, you can see that, so here we have to use the axis. Okay, here is the first axis, so which is having a dimension of, so you can see that, so the first axis we have to use, this is the first axis, so which is having a dimension of 60. So that is the first axis, and the second axis length is this which we have to measure. This is around 46 mm. Okay, so this is around 40. This is our second axis, 46. Okay, the second axis. So first axis is this, and second axis is this. First axis 60 mm. So here we follow the concept, that is, first I will take this axis length 60 mm. Okay, after that I will be using this. First for that I will be marking a reference point here, reference point of O, and I am measuring this length, that is 60. You can see that this is 60, I am measuring it. Measured, and I am cutting the arc here. So this I will give it as O2. Okay, O2, and here I will be drawing the locus line. Okay, locus line. Then again, the second axis line we have to consider this O2, O1. Consider, and I have cut the arc. This is O1. Now I am joining this. This axis, the next end. So now you find out the angle of inclination here. So the angle of inclination here I am getting around 40 degree. Okay, so this is beta 40 degree. Okay, beta 40. Now we have to transfer this diagram over here. That's it. You can see that already we have drawn O1 line here. O1 it is already drawn. So we have to transfer this diagram. Just I will extend this line little bit. Now using arc method we can transfer the diagram. You can see that already we have on this line we have A1, O1, C1, A, O and C. So we can cut the arcs by measuring from the compass from O1 to A, O to A, A1. So we can cut the arc. Similarly we have O to C1, O to C1. This is A1, this is C1. Similarly we can cut the arc from here also. That is O to C and O to A. Okay, this is A and this is C. Now on the same line we have all the things. Now using compass we have to construct these diagrams. Okay, A1 to D1. If you measure one length it will be same A1 to D1 and A1 to C1. Okay, A1 to D1 and then same length, so you can take and cut the arc. Okay, so this is your D1 and P1. The same length, it is same for your AD also, AD and CD, it is same. So it is D and this is B. So now we will join this. Okay, so wherever the dashed line is there, we'll construct with the dashed line. Okay, wherever continuous line is there, we will construct with the continuous line. Okay. So now you see that we have to construct the final position. So for that, first I will take this top face and this top face will finish the notation. It will be easy to do it. So D will be extending till here. Okay. So this is here we have D dash. Similarly we have here we have A dash. This is C dash. This is B dash. And this is O dash. Okay, so top view notations. Similarly we can do for the bottom face. This is D1 dash. Here we have A1 dash. This is B1 dash. this is C1 dash, this is O1 dash. Okay, so we have did this. Now we know the concept. Okay, so we have to consider the nearest point to the x value in the top view, that is fifth position, that is D. So D is the nearest point, correct? D is connected with C and D is connected with A and D is connected with D1. So D is connected with A and D is connected with C and D is connected with D1. So these are the dashed lines. Okay, so that's what the concept. D connected with C, D is connected with A and D is connected with D1 are the dashed lines. So first we'll finish with the dashed lines. D is connected with C, that is D dash, C dash will be dashed line, and D dash to A dash also dashed line, then D dash to D1 dash also dashed line. We have done with the dashed line. Now continuous lines. The top face will join. Okay, and now bottom face. So bottom face you can connect now the vertical edges. Okay, A dash, A1 dash can join. Similarly, C dash and C1 dash, and B dash and B1 dash. Now finally the axis, so I can join this. So these are we complete the problem.